Hi guys, here we are at Hemus 2022. Again, we're on the second day, and we're actually here with a gentleman called Volker Brands, who is the regional sales manager of Narda Safety Solutions. It's their very first time at Hemus this year, so we're really looking forward to hearing a little bit about what their solution does. And their solution is called SignalShark. And this is the equipment here. Volker, what does it do?
So this is a combination of a receiver for radio signals coming over the air. This is connected with an object, so we call SignalShark because it's looking into the signals, not sharply. And we use the name shark because shark has more than 6 senses, so more senses than humans have.
Okay.
So it actually can feel electromagnetic fields, because it can listen to the heartbeat of animals, and by that it's a good predator. You can sense these animals and eat them.
Okay.
So that was the idea and the link to the signals over the air, which we as humans cannot smell, neither taste or detect. This is connected with the ADFA automatic direction finding antenna. And out of this combination, we can get both. We can get a signal detected. We can get a signal directed, so from which direction it's coming. And ultimately, a bearing line can be put on a map. And with a second bearing line from a second position, you can do the so-called cross bearings. You see the localization of an emitter like this one, which could be an intentional emitter, unintentional emitter, illegal emitter, and even emitters which can ignite bombs or something like that.
Okay, so essentially, from what I understand, from what you just explained, this detects to a very, very high level of accuracy where a radio frequency is being transmitted from. So it can detect a mobile phone, and a radio, and a remote
satellite
communications as well. Okay, so then
radar also.
Really?
So other emission, which could be of relevance to generate metadata, and then, for example, to find the Red Army communicating.
Okay.
Or terrorists, if you think of asymmetric threats. So if the road is clear, if the canal is clear, where you're just shipping or whatever.
Okay.
And then finally, maybe to explain is that we have this in maybe I can speak. We have that in 3 form factors. So you can put the SignalShark and the ADFA in a car, like what you see.
So that's vehicle mounted.
What you see there. Or you can hand carry the SignalShark, and use it by walking around. And the best thing is all these 3 form factors, outdoor on a mast, rack mount in the vehicle, also ship, and handheld, they can all communicate with each other. So they can show the bearing lines of all 3 sides at the same time. Okay. The more bearing lines you have, the lower is the uncertainty, the measurement uncertainty, the higher is the accuracy has.
So I'm very interested in the soldier mounted, the unmounted soldier over there. What kind of range of detection does that particular operator get by using it?
That always depends on the strength of the signal you're sending. Of course, the gain of the antenna and the receiver sensitivity.
Okay.
But explain with other words. We optimize that, so you already have in the handle you have a preamp, so that the signal already, if you receive it in the handle, is being pre-amplified. Okay. So that also this cable has not a negative effect in terms of getting distorted signals or attenuating the signal. So you have already strong signal right from the handle, and then the SignalShark with its very high dynamic and high sensitivity input range. That means, technically speaking, a low intrinsic intermodulations. IP2, IP3, second order, third order harmonics intermodulations, so that you still can see very weak signals in the presence of very large signals. Yeah? That is always a challenge, especially in warfare, that you have strong signals like your own radios, like radar, like satellite uplinks going to the satellites up in the air. That you want to see very little signals which are at critical frequency ranges, where typically the Red Armies or terrorists are using in a special band, so that you still can see and identify it and locate it.
So you have almost like a special spectrum to identify those particular communications, nefarious communications. Very, very interesting.
Plus, maybe on that, what we also can do, we have a couple of partners which are taking this demodulated signal, which is called IQ data, which is digital demodulation. And as we have a quad-core Windows 11 user interface system here, these quad-cores still allows to have third-party demodulation and decoding software. So you can do signal classifications. For example, if you are on a ship, on a vessel, and you approach the ship, and then the security guys see an emission and decode the emission and see, for example, that somebody is starting a communication with a satellite phone, maybe a Turaya satellite phone, yeah? Then you can already get from this metadata information that this guy is maybe now calling his headquarters and is asking, getting approached by petrol, what should I do? Yeah. So you get a radio ID tagging, yeah, and have metadata about the person you are approaching or the vessel which is approaching you.
I understand.
And have better situational awareness hence.
That's very interesting. So what kind of, obviously we have military applications for this, that's detailed very well there. What kind of environments would you use this in say, Western Europe? Would it be for the protection of head of state, or is it security forces?
Actually, the reason why we came to that exhibition was the parallel seminar running about Horizon 2020, a European-funded project. And Narda, together with its partner Decodio, is partnering in the Nestor project. And the Nestor project, as the abbreviation is explained here, is an enhanced pre-frontier intelligence picture to safeguard the European borders. Yeah? So this is a semi-civil application, but borders can be protected in peace times, of course also in war times, and the mechanics and the applications and the functions are of course quite similar.
Wow. Well, it's been very, very interesting to talk to you, and I think we need to probably come back and speak to you in a couple of years' time, hopefully, when the Nestor project's really off. But thank you very much for coming and allowing us to speak to you today. And hope you enjoy the rest of your rest of your stay in Bulgaria.
Same too.
Thank you very much. Thank you.